Hello everyone, welcome back to another episode on the Education Always channel. Today we will be looking at groups in the periodic table. In this video we will cover Group 0, Group 1 and Group 7. First, Group 0. Group 0 contains non-metal elements placed in the vertical column on the far right of the periodic table. The elements in Group 0 are called the noble gases. They exist as single atoms. The noble gases all have low boiling points. Helium at the top of Group 0 has the lowest boiling point of any element. The attractive forces between the atoms become stronger. This is because going down Group 0, the atoms become larger, the intermolecular forces between the atoms become stronger, and more energy is needed to overcome these forces. Compared to other elements, the noble gases are inert. They are extremely unreactive and do not take part in chemical reactions. The table shows the electronic structure of some noble gases. All the noble gases have complete outer shells. Helium has only 2 electrons, the other elements have 8 electrons in the outer shell. When elements react, their atoms complete their outer shells by losing, gaining or sharing atoms. Atoms of Group 0 elements already have stable arrangements of electrons. This means that they have no tendency to lose, gain or share electrons. This is why the noble gases are unreactive. Group 1 contains elements placed in a vertical column on the far left of the periodic table. The elements in Group 1 are called the alkali metals. The alkali metals share similar physical properties. For example, they are soft, have relatively lower melting points and have low densities. Atoms of Group 1 elements all have 1 electron in their outer shell. This means that the alkali metals all have similar chemical properties. When a Group 1 element takes part in a reaction, its atoms each lose 1 electron. This forms positively charged ions. The ions have a stable arrangement of electrons with a complete outer shell. The alkali metals react with water to produce a metal hydroxide and hydrogen. For example, sodium reacts with water, which is sodium add water gives you sodium hydroxide and hydrogen. Sodium hydroxide is an alkali. It is a base that dissolves in water to form an alkaline solution. This solution has a pH greater than 7 and turns the universal indicator solution blue or purple. The table shows the different elements in Group 1 and their observations when added to water. The Group 1 elements react with oxygen from the air to make metal oxides. At room temperature, oxygen reacts with the surface of the metal. This forms a white oxide which covers the surface. The metal below the surface does not react. The alkali metals burn vigorously when heated and placed in a gas jar of oxygen. The oxide forms as white smoke. For example, sodium add oxygen gives you sodium oxide. The reactivity of the Group 1 elements increases down the group, so their reactions with oxygen get more vigorous. The Group 1 elements react vigorously with chlorine. The products of the reactions are chlorides. At room temperature, the chlorides are white solids. They dissolve in water to form colourless solutions. For example, sodium add chlorine gives you sodium chloride. The reactions with chlorine get more vigorous going down the group. When a Group 1 element takes part in a reaction, each of its atoms loses its outer electron to form a positively charged ion. The more easily the ions form, the more reactive the metal. Going down Group 1, the atoms become larger, the outer electron becomes further from the nucleus. The force of attraction between the nucleus and the outer electron decreases, the outer electron is lost more easily. The table shows the electron arrangement of each element in Group 1. Group 7 contains non-metal elements placed in a vertical column on the right of the periodic table. The elements in Group 7 are called the halogens. The halogens exist as simple molecules. Each molecule is made up of a pair of halogen atoms joined by a single covalent bond. In all groups of the periodic table, the further down the group an element is, the higher its relative molecular mass. The table shows the colour and physical states of chlorine, bromine and iodine at room temperature. In Group 7, the further down the group an element is, the higher its melting point and boiling point. This is because, going down Group 7, the molecules become larger, the inner molecular forces become stronger, and more energy is needed to overcome these forces. Atoms of Group 7 elements all have 7 electrons in their outer shell. This means that the halogens all have similar chemical reactions. When a Group 7 element takes part in a reaction, its atom gains each 1 electron. These atoms form negatively charged ions. The ions have a stable arrangement of electrons with a complete outer shell. The halogens react with metals to produce salts. The salts are made up of ions which are held together by ionic bonds. For example, chlorine reacts with sodium. Sodium and chlorine gives you sodium chloride. Sodium and chlorine react vigorously when heated, giving an orange flame and clouds of white sodium chloride. In Group 7, the reactivity of the elements decreases down the group. The table describes what happens when halogens react with iron wool. The halogens react with non-metals such as hydrogen. When a halogen reacts with hydrogen, the product is a compound called a hydrogen halide. For example, chlorine reacts with hydrogen. Hydrogen and chlorine gives you hydrogen chloride. The hydrogen halides are gases at room temperature. They dissolve in water to produce acidic solutions. Hydrogen chloride dissolves in water to produce hydrochloric acid. The table describes what happens when halogens react with hydrogen. It shows that the reactivity of the elements decreases down the group. A more reactive halogen can displace a less reactive halogen from solutions of its salts. For example, chlorine is more reactive than iodine. A solution of chlorine can displace iodine from potassium iodine solution. Chlorine plus potassium iodide gives potassium chloride plus iodine. The reaction mixture turns darker as iodine solution forms. When a Group 7 element takes part in a reaction, its atoms each gain 1 electron. These atoms form negatively charged ions. The ions have a stable arrangement of electrons with a complete outer shell. Going down Group 7, the atoms become larger, the outer shell becomes further from the nucleus, the forces of attraction between the nucleus and the outer shell decreases, an outer electron is gained less easily, and the halogen becomes less reactive. And that's it for today. Thank you everybody so much for watching. Please don't forget to like and subscribe for more. Any questions, put them down below in the comments. Thank you. Bye.